So let us start the history of toxicology. Regarding the history of toxicology is concerned, this has been divided into two parts. One is ancient toxicology, another is modern toxicology, depending on the time. So first we have to discuss the ancient toxicology, under which we are going to discuss the name of scientist who did something for the toxicology. So in this, the first one, we know about the prescription, the medical record in written form, that was Ebers Papyrus. So what is Ebers Papyrus? Is a written document in which you will find medical record of several drugs as well as the prescription, as well as you will find several poisonous agents are there. Thereafter, we are going to discuss about the Hippocrates. So Hippocrates, he did something for the toxicology, and he was called as father of modern medicine. And thereafter, one more scientist came. The name of the scientist was Pedanius Discorides. So Pedanius Discoride, he made first attempt to classify the poison on the basis of the origin, and also wrote 5 volume book called De Materia Medica. Thereafter, Geber ibn Hajar era came, and he also tried to classify drug and poison, and he told, if you are going to take a drug at higher dose, that become toxic or become a poison. Thereafter, Mose ben Maimon came, and he wrote the treatment of poison as a book, and we are calling it Maimonides. And the name of the book was Treatise on Poisons and Their Antidote. Means they are going. He discussed about the poison as well as the treatment, particularly poison concerned to the bites and stings. And the last one under the ancient toxicology was the Paracelsus. He was born as a Philippus Aureolus Theophrastus Bombastus von Hohenheim, and he was the scientist. He gave the concept of poison or a remedy, and he differentiate a poison and a remedy on the basis of dose. So dose become a poison and become a remedy he gave. And sometime in some book you also find the Paracelsus is a father of toxicology, not modern toxicology. That is the, you can say, the ancient toxicology. So father of toxicology, you can say the Paracelsus. Now we have to discuss one by one in broad way. So first we have to go through the written record, the oldest, one of the oldest written record, that is the Ebers Papyrus, and that was used in Egyptian medicine. And that written record is a medical record, have many prescription, as well as also discuss about the many diseases, and that was used in the history by the Egyptian. So that is why they called it Egyptian medicine. In that book, not only they have discussed about the prescription for the treatment, but also discuss about the poisons like aconite. So aconite earlier it was used as a arrow poison. Then another poison that we are calling it the queen of poison, that is the opium. So opium is not only a poison, this one also used as a antidote. And in the same book, the discussed about the some metal, toxic metal, that is the lead, copper, antimony. So this is about the Ebers Papyrus. Now we have to go through the Hippocrates. So Hippocrates is called as a father of modern medicine, and in Hippocrates school they knew about the toxic substances or element like metal, lead, mercury, copper, and antimony. In this school, Hippocrates thoughts school, they are knowing about these metals. And first time they advocate, they initiate poison, initiate vomison to prevent the poison absorption or absorption of poison. As you know, when you induce vomison, that means the contents, poisonous content present in the gastrointestinal tract, that will take out from the GI tract, and simultaneously they are going to check the absorption of poison. So that one is first time mentioned by the Hippocrates, that is the father of modern medicine. So later on, one more scientist came. The name of the scientist was Pedanius Discoride. And what is important about this scientist is that he is the scientist who first time tried to classify the poison on the basis of origin. Means ki it may be the animal poison, it may be the vegetable poison, it may be the mineral poison. So the first time the scientist Pedanius Discoride tried to classify, and he was a Greek army physician, and he served in the court of Roman Emperor Nero, and he wrote a book, and that book was the 5 volume book, and we call it De Materia Medica. And you have to recall this De Materia Medica by DE. So discoride start with D, and De Materia Medica is also start with D. So you have to recall by this way. Later on, scientist Geber ibn Hajar come. Geber ibn Hajar came, and he was the Persian writer. And he also tried to classify poison and a drug. Likewise, the Discoride, what he classify? Discoride classify the poison on the basis of origin. However, Geber ibn Hajar, he classify drugs and poison, and he told if you are going to take a drug at higher concentration, at higher amount, the same drug become the poison. Later on, the scientist Moses bin Maimon came, and he was Swiss philosopher, and he wrote a book, and we called it on the basis of his name Maimon, Maimonides. So Maimonides, the name of the writing is called Maimonides, and the name of the book was Treatise of Poison and Antidotes. What it means, in that book he mentioned about the poison, particularly the bites poison, and he also discussed about their antidote. So this is very, very important and is interesting. And he described about the bites of a snake, bite of insect, and bite of mad dogs, as well as their prevention and control or antidotal therapy or measures. So Maimon wrote the book called Treatise on Poison, as well as its antidote, that means their treatment. Thereafter, the last in the series of the ancient toxicology. The name of the scientist was Paracelsus, and he born as a this Philippus Aureolus Theophrastus Bombastus born Hohenheim, and he first time differentiate a poison and a remedy on the basis of the dose, and that is why he is sometime called father of toxicology. But you will find the older book, the father of toxicology, not modern toxicology. Father of toxicology is Paracelsus, and he told nothing in this world is non-poisonous, all substances are poisonous. Only the dose which will differentiate a poison and a remedy, and he has gave the concept of dose response relationship, as well as later on that basis therapeutic index was developed, that is developed by the which scientist, Paul Ehrlich. So that's what was the statement of the Paracelsus: all substances are poison. There is none which is not poison. Only the right dose differentiate a poison and remedy. So this is very, very important, and only on that basis it may be he called as the father of toxicology, not modern toxicology. So now we have to go through the modern toxicology. Under the modern toxicology, there are about more than six scientists participate in the development of toxicology, but we are going to discuss only the six. In these, the few that are very, very important are among these all the six, like Sertaner, Orfila, Megendai, Levin, Hermann Muller, Schrder. Amongst these all, the Orfila was very, very important. MJB Orfila. Why this scientist was important? Because he called as father of modern toxicology, and he was the scientist who separated toxicology as a separate discipline. He was the scientist who defined toxicology as a study of poison. So that is why Orfila or MJB Orfila called as the father of modern toxicology. Other than that, there are two scientists who took very important participate very importantly in modern toxicology are Hermann Muller and Gerhard Schrder. Why? Because Hermann Muller was the scientist who told or who discovered insecticide DDT, sorry, DDT, and he gave the insecticidal property of DDT. And this DDT revolutionized the insecticidal property. And this DDT, because of this DDT, Hermann Muller he awarded with the Nobel Prize. And this DDT is also going to kill the vectors like which carrying the malaria or other disease carrying. So this insecticide, at the time of discovery, become revolutionized the history, and thereafter one more scientist, Gerhard Schrder, he also, you can say, did very good work, but actually he was working on the insecticide, discovery of insecticide. But by default, while developing an insecticide, he developed nerve toxic nerve gas, and that is why the Gerhard Schroeder called father of nerve agent, because he developed in place of insecticide, he developed nerve gases like tabun, sarin, and daldrin. So that is why this scientist become very very important. So now we have to discuss one by one. So first we have to discuss about the Friedrich Sertiner. So why this Sertiner is important? Because he was the person who separated alkaloid morphine from opium. That is the queen of poison. Opium is a queen of poison, and he isolated an alkaloid from the opium called morphine, and the name was on the basis of Roman god of sleep, Morpheus. So name was morphine. Why they have given this name? Because this morphine is a narcotic or sedative. So going to keep the person calm and quiet, going to keep the animal calm and quiet, going to produce sleep. So that is why the name was morphine. Thereafter, the Orfila, as earlier I have mentioned, the Orfila was the scientist. He was the Spanish scientist, also a modern father of toxicology. Why he was the father of modern father of toxicology? Because he separated toxicology as a separate discipline, as well as he also defined toxicology is the science which discuss about the study of poison. So that is why Orfila is very very important. Not only that, he wrote many books that came in the name of toxicological general, and he did or initiated toxicological experiment, and he has mentioned in this book. So this is very very important. Now we have to go through the other scientist, Magendie, Francis Magendie. Francis Magendie, he described the alkaloid like morphine, imetine, and strychnine. He discussed about these alkaloid like morphine from opium. So imetine, that is used to produce emesis, vomison. Strychnine is a poisonous plant, name as Strychnus nux vomica. This is going to inhibit the release of acetyl neurotransmitter acetylcholine, and also discuss about the other alkaloid. Later on, another scientist, Louis Levin. Louis Levin books is still coming. The Louis Levin book, that he was a German scientist. He wrote many articles as well as the many books, and in that article and books he was mainly or primarily mentioned about the toxicology of methyl alcohol, ethyl alcohol, as well as chloroform and opium, and he published important publication, these publication in toxicologist view of world history, as well as wrote a book, textbook of toxicology. So later on, another scientist called Paul Hermann Muller. So why this is important, Paul Hermann Muller? Because he discovered insecticide DDT in the year 1939, and because of that he received Nobel Prize in 48. Why this insecticide was important? Because this is an insecticide usually used for the floor, and this is going to kill the vectors which were carrying the diseases like malaria, that is like the yellow fever. So that is why he awarded with the Nobel Prize. And under this series, the last one under the modern toxicology was the Gerhard Schrder. And Gerhard Schrder, actually by default, he developed the nerve gases and toxic nerve agent. We are calling it the serine, tabun, soman, cycloserine, and these are going to be used as a biological warfare agent in this now current era. So, but he was actually not intensely developed. This was developed by just accidental, because he was developing the insecticide. In that work, he did this one, and he also introduced, which who Gerhard Schrder. He also synthesized synthesis insecticide. We are calling it the organophosphorus insecticide. So this organophosphorus insecticide have a structure that is going to inhibit an enzyme that we call cholinesterase. So cholinesterase is an enzyme which is going to be blocked by synthetic insecticide, organophosphorus insecticide, and that is why he called as the father of nerve agent. So this is all about the history. So first toxicological modern book is published by the Casret and all. So you have to recall this first modern toxicological book was published by the Casret and all, and that is the modern book, that is the very very important. So you have to recall this one also. Now we have to go through the source and classification of the poison. So as the first time who have trying to classify this on the basis of origin, Pedanius Discoride, he tried to classify the poison on the basis of origin. So here we are also going to discuss the or classify the poisoning, source of poisoning on the basis of origin. So on the basis of origins, poisons are divided into two types. One is called natural source and another is called man-made sources. So one is natural, another is man-made sources. So we have to discuss one by one. So one is natural. Under the natural, what are the things is coming? The plants is coming, the animals is coming, the microorganism is coming, the minerals is coming. So under these natural sources of poisons are plant source, animal source, microorganism source, and mineral source, and these are very very important. So first we have to discuss the plant source of the poisoning. As we know, if a plant that contain more amount of poisonous ingredient, usually the animals are not going to eat. Only in famine condition, or if the unavailability of the grasses are available, then because of unavailability of plant and grasses, animal are going to bind to eat the poisonous plant also. So poisonous plant are Lantana camara, this is hepatotoxic plant. Then the Dhatura control the like the alkaloid like atropine. As you know, atropine is a muscarinic blocker. Then opium, as you know, this is the poppy plant from which we isolated the morphine alkaloid. Then oleander plant, that is a ornamental plant and which is cardiotoxic plant. Then the plants, many plant that contain toxic ingredient like cyanide. So cyanide containing plant, nitrate and nitrite containing toxic plant. Then oxalate, that is the oxalate containing plant. These two, cyanide and nitrite, they are mainly produce the toxic related to the respiration. Or finally, when the animal are going to die by the cyanide and nitrate and nitrite, they are usually going to create the problem with the oxygen carrying property of the hemoglobin. They interfere with that one. And regarding oxalate is concerned, this oxalate is going to form the crystal, or you can say chelate the calcium. So and therefore this oxalate containing plant is going to form the calcium oxalate and chelate the calcium from the body. So other toxic plant on the basis of their toxic affected toxic organ are cardiac toxicity plant, photosensitization causing plant like Lantana cabara, and plant and crop and grasses are grown in those areas where some toxic minerals are in high quantity, then these plants may contain a high concentration of these toxic minerals and become toxic when the animals are going to eat. And these are arsenic, selenium, molybdenum. So this is when going to contain plant arsenic. So arsenic toxicity, then selenium toxicity, molybdenum toxicity. So this is all about the plant. Now we have to see the animal poisoning. In animal poisoning, this is mainly concerned to the biting of toxic animal or stinging, that is the stinging of the wasp. So these biting or stinging of poisonous animals like reptiles, like amphibia, like arachnid, like insect, like under this the examples are a snake bite, then a spiders, then a scorpion, then the toad, that is the frog, then the bees and tetrodotoxic fish. So these all are the animal and they are having the toxic substances for its defense, and when they are going to bite the animal they are going to produce the poisoning. So this is all about the animal poisoning by the biting or stinging of the poisonous animal. Now we have to go through the microorganism producing the poisoning. In this microorganism, bacteriotoxin is very important. Bacterial toxin, under the bacterial toxin, some bacteria that is going to produce in the food toxin, that release the toxin, that are the that toxin are the botulinum toxin. Bacterial toxin is the botulinum toxin. So as you know, this bacterial toxin, botulinum toxin, is produced in the food. So those animal are going to take this food, they are going to produce the botulinum toxicity. So botulinum toxicity, the mechanism of action of this one, this is going to inhibit the release of endogenous neurotransmitter acetylcholine. So this is the mechanism of action of the bacterial toxin, botulinum toxin. As well as the toxin microorganism are mycotoxin, and this is very important, and that is coming with the food. So this bacterial toxin botulinum and mycotoxin, these are coming with the food and feed contaminant, because this is present in the food or the grains, like mycotoxin, like hepatotoxic mycotoxin, like aflatoxin, rubra-toxin. These two are the hepatotoxic mycotoxin. The other mycotoxin are ochratoxin, that is also found in the food, and that is called nephrotoxicity. Then zearalenone, that is also the mycotoxin, that is the estrogenic one. So these all are the poisoning produced by the microorganism. This is also the natural sources, and some of the bacteria also releases the poisonous gases like hydrogen sulfide and ammonia. Also marine organisms, they are also possessing the toxic substances, and the organisms are dinoflagellates, which produce toxin that accumulated in the food, the marine food. Now we have to go through the minerals. So as I earlier mentioned, in those areas where some of the toxic mineral are found in very high concentration, that is going to contaminate the sources like water. So this is very important, and also may accumulate in plant, because when you are going to grow the plant in these area, so when you are going to take out the water from the well, and in that area, if the minerals are high concentration, then this is going to produce the poisonous. And these minerals are selenium, arsenic. So as you know, some areas of the West Bengal and also the Bihar, also JK, and nowadays the many areas of the states of different state of the country India, there you will find the high concentration of fluoride and arsenic, and these items will come in the water, and therefore it will produce the toxicity in the human being, and as well as the animals. As you know, fluoride that is going to produce the bone porosity. So this is very, very, very important. Arsenic is also coming into the water. Then the selenium, then molybdenum, then the copper. So these are very, very important natural source of toxicity or poisoning. And this is all about the natural source. Now we have to go through the second one, and the last one is the man-made poisoning. So if you go to consider this, man-made poisoning may be reduced. I am not going to tell you have to curtail it, you have to delete it, but you have to reduce it. Now, as we have seen in this lockdown, that this man-made poisoning is reduced in our environment. So this is very, very important, and you have to curtail it. You have to reduce it. Amongst these are the types are industrial waste. So as we know that these days industry get closed, then agrochemicals, then household products, then the therapeutic agents, then the feed and food and water contaminants on waste, environmental pollution, then the improper management, then the accidental poisoning, and then the occupational poisoning. Under this I and J, this is not much well coming under the man-made, but even though this is man-made, as you know, accidental poisoning, just recently we have go through this one in the in this lockdown, and we have seen the Visakhapatnam treasury. In that that one we have seen the leakage of a gas. We called it Vijag gas, and this Vijag gas leaked in Visakhapatnam, and you have seen there was a death occur. As well as we also have seen the Bhopal gas tragedy in our country, and that one because of the methyl isocyanate leakage. Also in this Japan, we have seen the nuclear power station, and there the leakage of the chemicals there. So now we have to go through the first one, the industrial waste. So under the industrial waste, that is the main made source, and the industry that are in our society, present in our society, they are the most common source of the poisoning. Under this industrial waste, these industrial waste is coming as a form of effluent, and because the most of the company, they are not going to have a scientific, if that we have to destroy this effluent. Therefore this is going to contaminate our rivers, and that is going to contaminate rivers, organism residing in the rivers, and these river get polluted, and these pollution is going to produce the toxicity. So this industrial waste, as in the form of waste, in the form of effluent coming in the rivers, therefore this is going to accumulate there, and therefore going to produce the toxicity because of the presence in the organism residing there, that is like the fish. And these chemicals may be the chromium, may be the nickel, may be the mercury, may be the lead, may be the polychlorinated biphenyls, and whatever the items we are using in the industry, they are going to contaminate the rivers. And one of the most important outbreak or disaster came in the history was the mercury toxicity, and that reported from the Japan, and the Japan, and the place was and the disease was we call Minamata disease, and that is because of the mercury toxicity. And this mercury is coming in the river, and that get accumulated in the plankton, and therefore accumulated in the fish, and the person residing in that area, they ate this fish and produce the mercury toxicity, and that occur in that bay. We are calling it the minimata bay, and therefore it produced the toxicity. So that was the minimata disaster, and the toxicity because of the mercury that is effluent coming from the industry in the rivers. And other than that, industrial waste are gases also, vapor also, dust also. Amongst the importance are sulfur dioxide, nitrogen dioxide, chlorine gases, and that is going to affect the animal, going to produce the animal poison. Now we have to go through the agrochemicals. Agrochemicals means the chemical used in agriculture. It's called agrochemical, and this is one of the most usable insecticide, fertilizer, fungicide, and this is most usable one. So, and this therefore this is going to produce the toxicity. How? When you are going to use fertilizers, this is going to affect the soil coming in the plant, eating by the animal, and produce the toxicity. Then when you are using fungicide at the herbages, then again going to eat by the animals, coming in the plant and eaten by the animals and produce the toxicity. If you are using the rat baits to kill the rats at the farms where the rats problem is there, as a rodenticide. So these rodenticide, when the animals are ate these, that is going to produce the poisoning in the animals, small animals and birds. And these rodenticide like red squill, warfarin, zinc phosphide. Now we have to go through the major agrochemicals as a insecticide that we are using, still we are using DDT, even though this is the ban one, because these all are the organochlorine insecticide: DDT, benzene hexachloride, and dieldrin. These all the three are the organochlorine insecticide, and the among that the DDT is banned because of the biological accumulation. But still we are using in farm, in lawns, in houses, and therefore this is because they are get bioaccumulated, and because of the bioaccumulation this is going to produce the toxicity. And this is the one of the biggest source of accidental poisoning in all species. How? This is by mistake is taken by the animals. And now we have to go through the household product as a toxic one. So in household product or source of the poisoning is the most important is the phenols. That phenyl that we are using for the floor, that is most usable nowadays in lockdown. This is most usable phenols as a disinfectant. This is going to produce the man-made source of the poisoning. Then we are also using the cleaners like TV, like fridge, like anything that we are having the then a spot remover. And the most important is also naphthalene ball. We are usually using this to keep in the clothes. So naphthalene ball and the phenyl, these two are the very important household product that we are using. And nowadays this cleaner, spot remover, nowadays we are indiscriminately we are using nowadays because of this COVID infection. Now we have to go through the toxicity because of the therapeutic agent that we are using. Now we have seen in this lockdown that the chloroquine, this is a drug as a anti-malarial drug, and we are using nowadays as a preventive measure for the COVID. But this chloroquine is having, if you are using indiscriminately, then this is going to produce several toxicity like chloramphenicol. When you are using chloramphenicol in the kid, this is going to produce the toxicity like the nephrotoxic antibiotic we are using, that is the aminoglycoside. Now this also depend on the route of administration, also you on the dosage, also in the improper species, like improper species like paracetamol. Paracetamol is going to be metabolized also by glucuronide conjugation. So glucuronide conjugation require one enzyme, we are calling it UDP, glucuronyl transferase. So this UDP, glucuronyl transferase, that is called UGT, is deficient in cat. So when you are using this paracetamol in a species like cat and fish also lack this enzyme, then this is going to produce the paracetamol toxicity, because this is one of the metabolism pathway of the paracetamol. Now we have to go through the food and feed and water source of the toxicity. In this, when you are using, the most important is the genetically modified food. We don't know nowadays, still we are not aware that we are produce the brinjal, genetically modified brinjal. What this brinjal is having the effect in our society. We have not still done its experiment. What is its the genetically modified brinjal have the side effect in our society? Like the saccharine. What is this saccharine? Saccharine is the sugar that usually we are using in place of sugar for the sugar patient. But when we are using this saccharine in a higher concentration for longer time interval, that is going to produce, it had been seen that this is going to produce the side effect in the laboratory animal. So this is very important. Now we are going through the another one is the environment pollution. This environmental pollution is the very important source of pollution, poisoning, like the carbon monoxide poisoning. This is coming from the fossil fuels, like fossil from the burning of the petrol and diesel. Petrol and diesel that is going to produce the toxic gas like carbon monoxide, and from the battery that is coming, and also the leaded fuels. So lead is coming. So these are going to contaminate our environment and produce the toxicity. Amongst that one, the carbon monoxide. Nowadays, sometime we are listening that in the inside the car, when it get locked by on, this is going to produce the kill them the person sitting in that car. Only mainly and primarily because of the carbon monoxide toxicity, because of the burning of the fossil fuel. Also the burning of the coal is also releasing the carbon dioxide, also contaminating our environment. Now is also important is the improper management. Improper management means if the ventilation is not proper, if the crowding is over, that we are knowing nowadays, and if the diet is deficient in the nutrient, these all are going to aggravate the poisoning problem. Like this burning coal and fossil fuel in a closed area, this is going to produce the toxicity, more toxicity, like in car that we already mentioned. Now next is the malicious poisoning. What is malicious poisoning? By criminal killing of the animal. What is the meaning of criminal killing? By intensely we are giving, the poisoning, we are poisoning the animals by giving the insecticide, by giving the plants, therefore the animal is going to be killed. And the accidental poisoning that we already discussed, that is the like the methyl isocyanate, Bhopal gas tragedy, Chernobyl, that is in the USA, nuclear disaster, that is now this Visakhapatnam gas leakage. So this is all about your today class.